Hello everybody, welcome to another episode of Coyotiv School of Software Engineering Public Lectures. This is Armağan Amcalar from Coyotiv, and here we are on week 4 of our public lecture series. And today we're going to talk about Node.js again. This is Introduction to Node.js Part 2. It's not covering the entire curriculum about Node.js. Of course, it's kind of impossible. So we just want to give you a sneak preview at what you should expect working with Node.js. We did the first part last week, and here we are this week to do the second part. And today we're also going to talk about some exciting features, some useful features of Node.js. And we're gonna look into how to make use of files. We're gonna read files and write to files, and we're gonna see a little bit about asynchronous programming. But before we get started, I want to ask you how you're all doing. How is life? I hope you're all holding up well under these circumstances. I'm in Germany, Berlin. The numbers, the COVID numbers, and in case you're watching this, 10 years later, like if the year is 2025, 2030, you might not remember, but currently we're at the height of a kind of a crisis, a pandemic. We have a virus called COVID-19 because it kind of started last year, I guess. And currently the numbers don't look promising, but we have hope in vaccines, and we're looking forward to going back to our lives. So I hope everybody is doing well so far. Now, we're going to start with Node.js Part 2, Introduction to Node.js Part 2. Again, before we do that, I actually want to take a couple of minutes to talk about what we did last week, what we did in Introduction to Node.js 1. As a quick refresher, I'm going to go over the content a little bit. And we had a question during the stream that I might have misunderstood. I'm going to talk a little bit about that. And then also I'm going to talk about how Node.js is different than JavaScript. Is it not just JavaScript? This is a question that I received today about this lecture. Another student of mine asked when we were talking about this lecture, they said, is it not just JavaScript? So we're going to talk a little bit about that today as well and see how Node.js is different. Feel free to let me know in the comments what you think of the lecture. If there is something unclear, I'm going to try to reiterate the unclear bits and try to make sure you kind of get at least the core idea of Node.js. And yeah, without further ado, let's get started. Now I'm going to share my screen again, and this is the part that I hate the most, kind of. I want to make sure I do the right thing. I'm going to share my screen with you right now. I hope it's gonna work. And yes, okay, not terrible, a lot better than I expected. All right, perfect. Now you see my screen. This is week 4 of lectures, but basically the code base is the same. I just copied and pasted week 3, and you're going to be able to find everything we do today in our GitHub profile, github.com/coyotiv/public lectures. You're going to find all the code that we write today and everything we did in the past weeks in our GitHub profile. So now, since the code is exactly the same as last week's, I want to go over what we did. We created a new project, a new Node.js project, an npm package, by creating something called package.json, and we did that by utilizing the command npm init. Now you can also do npm init -y, and that basically gives you it doesn't ask you any questions. It automatically creates a package.json file that you can use to kickstart your development. But since we have a package.json file, we're not going to do that. And then we split up our code that was only in index.js and put it up in different modules. Like we have bank account JS, we have bank JS, we have user JS. So we split our implementation into multiple files. And here in index.js, we have the usage of these modules that we require. So we require bank, user, we create a new bank. I don't know why our bank is anonymous. That sounds shady. I think I would like my bank to have a name, but we're gonna see. Maybe later we can introduce a name. So we have a new bank and 2 users, and they are opening bank accounts, and then they're depositing money, withdrawing money. Steve is a lot richer than I am, so he invests, or he deposits $3 million in the bank, and I'm merely going with 300. And then in the end we have the bank balance sheet. This is where we left our implementation. So we talked about modules, and of course when we talked about bank account, we also talked about UUID. We talked about adding dependencies to our code and requiring those dependencies, and also making use of those dependencies. So here you see what I do is I create, whenever I create a new bank account, it automatically is created with an ID, with a unique identifier, which doesn't look like a bank account number. It's something else. This is an identifier dedicated to that record in the database. It's not bank account number, it's that bank account ID. And how we create it is via using UUID module v4 implementation. This is an industry standard, and we use that to create a unique identifier for our bank account. All right, and we didn't change the implementation. The implementation is the same from, I think, week 2. I'm not exactly sure. I'm not that good with dates and memory. I'm worse than an M1 chip with less memory. Hello, hi Ramin. Now, one thing that I want to talk about today is the question that we received last week. The question was, how is module.exports different than export? And at that time, I didn't understand the question. I thought that person was referring to the exports variable, like this, exports.bankaccount equals bank account, something like this. But I think that was not the case, because they were explicitly asking for export. So I think what they meant was, instead of writing module.exports, for example, why don't we just say export default class, something like this. And what are the differences? Now, there are a lot of differences in implementation, in how these things work. But, and I don't really want to go into details, because it's a little bit more advanced than what we would like to cover in these, beginner-friendly public lecture series. And Tamay, maybe in the future we can have a dedicated session about module resolution. But fundamentally, this is a standard JavaScript syntax that is not supported right out of the box on Node.js. This is something Node.js kind of invented. It's another standard, and Node.js kind of like accepted that. And this wasn't a standard insofar as the previous one. The previous one is a language standard. It's like ES6 language standard, this module definition. What you have is, in JavaScript, you have export default, and this would work in modern browsers, while this wouldn't work in modern browsers, because this is the CommonJS standard, if I'm not mistaken, and that is a third-party, community approach to modules, to building modules. So this is what Node.js uses in order to find, require and export different files. So this is bank account, and this is how we use it in index.js. Here you see we require our bank. This require syntax and this module export syntax is specific to Node.js. It won't work in a browser. Whereas this would work in a browser with certain configurations in the latest builds of these browsers. What happened? Looks like I'm not live. What's going on? I'm live. All right, because my my YouTube kind of like froze. I don't know why. Let me maybe open it again. I kind of use it like a mirror. I watch myself. Not just kidding. All right, yeah, I'm back. Perfect. So great. All right, what was I saying? So this requires syntax, and this module export syntax is unique to, well, not exactly unique, but it does not work in browsers. It works in Node.js. And if you want to use export default class bank account, like the new JavaScript syntax in Node.js, you have to change your file extension to m.js to indicate that it's a module, and then you also have to indicate it in your package.json that this is a module, so that we should use ES standard module resolution and not Node.js module resolution. It's a little bit unfortunate, really, how this thing panned out, but this underlines the fundamental difference between Node.js and JavaScript. Node.js is not JavaScript. Node.js is an app that can run JavaScript, and it understands certain syntax, a certain flavor of JavaScript, and currently that flavor, for example, does not include export default class bank account. If you write that, that's not going to work. It's going to be a syntax error. So this is drawing a very thick line between Node.js and JavaScript. JavaScript is the language that we use. Node.js is the environment that we run our JavaScript files. If you run index.js in the browser, there is no require source bank. A browser does not know how to understand this require, how to make use of this require. And if you want to use this syntax in the browser, you have to kind of compile your code. What you have to do is you have to run your code through another app like Webpack, for example. Maybe you have heard of it, which kind of bundles your code. It's called a bundler. There are other bundlers as well, but they understand the syntax, and then they find what user.js is or what bank account.js is, and then they kind of replace those declarations with the contents of each file. So Node.js is a runtime environment, which, if you remember from last week, means it's an app that runs JavaScript files. It's an app that runs JavaScript files. Therefore, it does not have to, and definitely does not support, all the features of JavaScript. Okay? I hope that's clear. There are a lot of other differences, but you might think, yeah, but it's very similar to JavaScript, right? I write, for example, there are callbacks, there are promises, there are async await. I write those in the browser, they work. I write them in Node.js, they work. The main reason for that is JavaScript. One, JavaScript is a very good standard, and two, Node.js uses Google Chrome's built-in JavaScript engine that's called V8. Chrome uses a piece of software, a library called V8 to understand and execute JavaScript. And again, Node.js is a thin wrapper around that V8 engine. So what they did was they extracted the source code from Chrome, the source code of V8 from Chrome, and built this ecosystem of libraries and turned it into an independent executable so that you can run it in your machine just by typing node index.js. Here you do node index.js and you see the output. And here we are. I printed the output. It's bank account balance. It's in index.js. We have bank balance sheet, and it's per user. So for each user and for each bank account, I have the account ID and then I have the balance. And that's where we left last week. I hope this was a little bit clear how Node.js is different than JavaScript. JavaScript is a language. Node.js is an app. JavaScript has a standard. Node.js implements that standard. So that's also another distinction, let's say. They are categorically different. One is like a human language, like English. JavaScript is like English, and then Node.js is like a play, a theater play. So what you do is you make use of the language and you create a story out of it. So you use the language. You don't have to use the language in the exact same way that it is defined. You're not maybe using the entirety of the language, but you're creating a story out of it. It's kind of like that. I know it's not a great example, but I just made it up right this second, so you have to live with it. All right, now let's get to this week's topics. First of all, I want to show you some files and file access and how we deal with files. And in order to do that, I'm going to look at my bank account. And here you see when we're setting a balance, what we do is we're saving the record in our transactions array. So what we have here is the transactions array has a list of all the balance changes in this specific bank account. And then, when let's open the bank here, when somebody asks us to print the balance sheet, what we do is we loop over each account that we have in this bank. And what we do is we go over each account and pick the user names and pick the account IDs and also take the balance. But we could very well take the transactions as well. For example, if so in our package.json, I also introduced scripts. So we have the dev script. If I do npm run dev, this is going to run indefinitely. And whenever I make a change, it will run again and show me the new results. So in the bank class, I can also, let's see if this will work. I can also write transactions and do account.transactions, and let's see if it's going to work. And here you see we can also print each transaction of that bank account. And I know it's not exactly transactions, it's the balances of each balance. So we first deposited $300, and then we withdrew 100, so that's why you see 200 here. We throw another 50 and another 50 and another 20, that's why you see 300, 200, 150, 180. So it's not exactly transactions, just to be correct. But now what I want to do here is I want to print these to a file. I want to write these to a file because I want to, process them later. It's great if I'm able to see the bank balance sheet whenever I want. It's really great. Like I do console log bank balance sheet and I see the current balance sheet. That's great. And also let me maybe remove transactions for now. So that's great. But I also maybe, for example, want my system to store the balance sheet every month automatically, so that I can look at my balance sheet for October, balance sheet for November, balance sheet for December, 2020, any year. That could be a cool implementation, and for that we need to write this balance sheet to a file. Okay, now whose responsibility is it? This is a genuine question for our viewers in the chat. Whose responsibility is it to print the bank balance sheet every month and save it to a file, let's say? Anyone? Where should we put that functionality? Printing the balance sheet to a file. And in this case, we're going to save the balance sheet as a JSON file. We will, basically what I expect is, whenever I call a certain function, we should see a new file being created. And then maybe I'm going to read that file. Okay, Fatih says bank is responsible for this. Good. This is the answer that I was looking for. And because it's the most common answer. Ask 100 developers that you see on the street. Maybe it's a conference, who knows? Ask 100 developers and maybe 90 of them will say it's the bank's responsibility. If it's the bank's balance sheet, the bank should print and save that bank balance or balance sheet, right? And let's go and see what the bank is doing. The bank can open an account, and then the bank has a property, a dynamic property that's computed as named as the balance sheet. In this regard, a bank keeps a record of accounts, internal accounts, and then they can open a new account, right? Now, given this specification, does it really make sense for the bank to have a function to also save the balance sheet as a file? What if in the future I will want to email that file? What if in the future I will want to, right now I'm saving it as a JSON file. What if in the future I want to save it as an Excel file? Is this the responsibility of the bank class to know how exactly to save that, that bank balance sheet? And the answer is, I'm afraid, no, this is not the bank's responsibility. This is an entirely different responsibility. Printing balance sheets of a bank is an entirely different responsibility than knowing what that balance sheet is. And again, I'm going to ask you to take inspiration from real life. What does it mean to print a balance sheet? What you do is you have a machine called printer, right? The name of the thing is printer. And its responsibility is to print whatever you pass it. So in real life, you have a dedicated machine just to print stuff. Why should it be any different in software? If we want to save this balance sheet into a file, like print this balance sheet into a file, maybe we should use a printer. Maybe, just maybe, just an idea. But I think it's a good idea, and I back that idea up very strongly. So that's what I'm gonna do. I'm going to add a new class. For now, I'm going to call it a printer. All right, it's gonna be a generic class. It's fine, and maybe today I'm gonna implement a file printer. Maybe in the future I'm going to implement different printers, but I'm gonna start with adding a printer class. And maybe it doesn't even have to be a class. Not every module has to be a class. So this time, let's not make it a class. Let's make it a regular function. And we start with module exports. It's going to be a simple function. It should take any list of contents. And then for now, let's print it to the console. We do console.log contents. All right. And let's update our index.js. Instead of doing the bank balance sheet here, what I want to do is to have the printer source printer. Okay. And then instead of directly logging it to the console, I just say printer, something like this. And then it still works. And if I replace this with hello, it's going to print hello. So it's legit working. Now, my index.js file does not know how to print something to the console. Okay, I hate this. I hate this during live stream to happen. But I have something from Amazon Prime now, that I need to take care of. I'm gonna ask. I'm gonna ask my girlfriend to take care of it. Thank you. All right. These things happen on live stream. You cannot escape from it. Especially during Corona times when you order stuff, you cannot really know when they're going to arrive. So now I have a printer. That means my index.js does not know anymore, does not need to know how to print the balance sheet, which is great. It's deferring that responsibility to another module called printer. And in fact, instead of this, we could also do exports.print, and then make it equal to this function. And instead of using it like this, we could say up here, const printer, require printer, and then we do printer.print. So this also works. We were talking about the differences between module exports and exports last week, and this is kind of an interesting implementation. What did I buy from Amazon? I think it's something very uncool. I don't know. I think it's Band-Aids. I think I got Band-Aids. It's what's arriving. Not fun. Nothing fun. I know it's not a PlayStation 5. But okay. So yeah, I think I like this printer.print a little bit more. It's a little bit better. it looks a little bit better. So that's what I'm going to use here. Printer.print bank balance sheet. Perfect. But it's not saving this to any file. So let's make that happen right now. Okay, I think danger averted. Perfect. Great. Now let's print this to a file. Sorry for the disturbance. Again, this was totally unexpected. I want this to print to a file in another folder. For this, Node.js has a module called FS, file system. So what I'm going to do here is I'm going to introduce that module, const fs require fs, all right? And then I'm going to basically use this module to write to a file instead of logging it to the console, all right? So here, instead of console log contents, this time I can do fs write file sync. For now, let's use this function. Output JSON, or let's say balance sheet.json, and then contents. Here, let's also activate word wrap. Yeah. So maybe this is a little bit better. So we have write file sync balance sheet JSON contents. Now, when you run this, you get an error. The data argument must be of type string or an instance of buffer typed array or something. Balance sheet is an object right now. It's an array of objects. So this actually, we cannot really print this. Node.js doesn't know, or FS doesn't know how to print this to a file. What you have to do here is to stringify those that content that's passed to you. And now, of course, you're gonna get an infinite restart via nodemon. You see it's flowing. It's a terrible idea, because what happens is every time this app runs, it prints the balance sheet to this balance sheet JSON. And then, since there is a new file that's modified, nodemon picks it up and restarts that that application. So actually, this is not fun. This is not what I was looking for. Because if I run npm run dev right now, it's gonna start restarting all the time. You can get around this with nodemon. I think it's, yeah. You can ignore certain files, and let's say we are going to save this under reports. All right, I have a new directory called reports. I want my balance sheet to be in reports, and this is also what I'm going to put here. Reports balance sheet JSON stringify contents. This is where I save it from now on. And now I'm going to ignore the reports folder. Let's hope this is going to work. npm run dev, and you see it works. Now, if I change, I don't know, balance sheets, if I call this balance sheet 2, then you see a new JSON there, and it doesn't restart. So this is how you ignore certain folders or files, so that nodemon doesn't run wild and restart every single time. So you have balance sheet and balance sheet 2. They are JSON files. They don't look very lovely. For that, you can introduce indentation. So you can actually make this JSON file look like a proper JavaScript object or very well indented object that humans can read. Of course, you don't do it manually. What you do is in JSON stringify, you have null. If you wonder what this is, look it up in JSON stringify documentation on MDN. And then you type the number of characters you want to use for indentation. In this case, I want to use 2. And you see here balance sheet 2 is very well indented. Balance sheet is not. I mean, it's the manual version that I had before. So you can automatically indent your stringified texts. You can say, I don't know, 8 here. And then you're going to see balance sheet is indented by 8 characters. Let's see if I can. So let's open the printer here. Let's say I want 2. And you see it automatically refreshes to have 2 spaces for indentation, which is great. This is amazing. All right. Now, what is the problem? We are able to write something to a file. Whenever we say printer.print bank balance sheet, we have it as a file here. Let's also have another module called reader, maybe, to read this. All right. Reader.js. And here, let's set printer here. Reader will be very similar. So I kind of copy and paste. Let's call this a read method. And this should have a file name, maybe, and then it's gonna read that, or let's call it a report name, and let's make this a string report name, and read file. Instead of write file sync, this time I'm gonna use the function read file sync to read this file synchronously. So this should be report name. How do I implement this? I go to index.js. I require the reader. Okay. And now I do reader.read bank balance sheet 2. Okay. Now I'm not printing anymore. I'm just reading it, and it's returning a string to me, or something like a string. Let's actually see what it returns. Const reports. Let's call this const report equals reader.read, and then let's do report console log report. Okay, when I log this, I get something like buffer 5B0A 2020 7B0A 2020 2020, something like this. So this is not this. This is what I expected to see. Interesting. I have 5B0A 2020. 7B0A 2020 2020. Turns out that this file that you see here is not stored exactly in this format. It is stored using something called bytes or bits. It's a binary representation of what we see here. And when we read the file, the raw contents that you get is unfortunately historically called the buffer, is a series of numbers. So when we save a file, our app converts this into a series of numbers. Every character that you see here is represented as a number. So for example, here, instead of this, let's type 1, okay? And let's restart. You see 310A. Let's type 9, okay? You see 390A. Turns out that every character in the alphabet has a representation in numbers, and the character 1 is represented as the number 3-1. This is hexadecimal, so this is actually, this converts to what does it actually convert to? 49. Yeah, I think this converts to 49. 48 is 30, and then you add 1, it's 49. Or, you know, 9 is 39. There are exactly like 1, 2, 3, 4, 5, 6, 7, 8, and 9. They are all lined up on 3, 1, 3, 0, 3, 1, 3, 2, 3, 3, and 3, 9. I'm not calling it 39 because it's not 39, or it's 39 on base 16. So it's 48 plus 9, which is, I believe, 57. I'm not very good with math. All right, so every character, and 0A is the line feed character here, is the enter character here. You see I have a new line here. So if I do 1, 1, 2, 2, 3, 3, and save it, you're going to see 31, 31, 32, 32, 33, 33. It's actually very, very simple. It's very simple. So what we get, therefore, is this raw record of numbers. What do we make of them? Each number is a byte. What do we make of these bytes? We have to convert them into something that's readable, right? That's understandable. For that, you use the second parameter of the read file sync method, and you do, for example, UTF-8. Okay, you save it, and then bam, you see a human readable version of that thing. Now, this is a string. You cannot do much with it. You cannot say, you know, get me the balance of the first. You cannot say get me the balance of the first account here. You cannot do report, you know, console. Yeah. All right. Let's do it like this. You cannot do report 0 balance here. If you do that, you're going to get undefined because there's no balance of report 0. It just doesn't work because this is string. What you actually need to do is to convert this into JSON again. So instead of returning it as a string, what we do is we do Json.parse. Okay. And then what we have here is an object. And now that is, hello, Steve. And here you have the details of that object, and you can log the entire thing. If you scroll up, you see it was lifeless before. It was colorless because it was a string, and now it is full of life. It's full of color because it is an object, and JavaScript kind of knows that this is a property, this is a value, and you can do report one.name, for example, .user, and it's going to return you Steve Ingram. And now this is a string. Or you can do, again, balance, and it's going to return 3,000,003. And these are yellow because it's a number. This is gray or white because it's a string. So far, so good. However, if you remember last week, what we said was, we said Node.js is an asynchronous JavaScript runtime that has non-blocking input and output. What is input and output? Input and output is exactly what we did here, reading files and writing files. Input and output. You take an input from the file system, you give an output to the file system. And here you see under reports, we have balance sheet to balance sheet JSON. So that's our output. Now, if you noticed, the names of the functions that we're using are read file sync and write file sync. What these do is these are operating synchronously. Okay, let me demonstrate what I mean. I have here printer.print, and let's get rid of these for now. I have printer.print. I write printing and then console log printing completed. Okay, I save this, and then you see I'm saying printing and then printing completed. And here you are updating in the printer we have balance sheet to. Here we are updating our balance sheet to JSON file with the latest details. Now let's also read that file. Read balance sheet 2, right? That's what we do. And also I want to log that. So I write something, I print, I read the file, and then printing completed is when I'm completely done with it. In fact, let's open the printer here. Okay, let's make this a multi-line function, and let's put those logs here as we would in a real-life application. Printing and printing completed. Okay, something like this. And now, whenever we are printing something, we see these logs automatically. And if I want to read my file before printing something, you see that I'm reading my file, right? Console log reader read. I'm reading my file, and then I'm printing my file. Printing and printing completed. That's great. This is synchronous operation. I'm reading my file synchronously, which means I execute this line, and then I come to this line, I go here, I wait, I read this file, and then after I read it, I print it to the console, and then I print a new file. All right, printer print bank balance sheet. Now, here is the issue. What if this file is very big? What if this JSON balance sheet 2 is very, very big? Let's say when I'm printing balance sheet 2, but I want to actually read balance sheet and not the second one. So I'm not interested in balance sheet 2. It's a completely different report. What if this file takes ages to read, ages to work with? The printer still has to wait, because this reader, since it's using read file sync, it's a synchronous operation and it's a blocking operation. It is a blocking IO operation, input output operation. We're saying that, hey, wait, until I'm done with this file, you cannot go on and do anything else. So that's pretty much how every other language in the world works. And that's great. But is it so great? It's not. Because what happens if we're not reading from our file system, but from a remote server? What happens if this is a request that I send over the internet? For example, what happens if I'm reading from Google storage or AWS S3 or any file on the internet? What happens if I'm reading from Dropbox? The network transfer would take a lot of time, right? Let's say this file is 1 GB. The network transfer will take a lot of time. Am I doing anything during that time frame other than downloading the file? I'm not. So downloading a file is inherently a single core operation. You assign one CPU core to downloading, and it does it maybe like with a utilization of 1%. So most of the time it's doing nothing. Why then do we wait until we get to the next line? Could we, as an idea, could we just say, let this operation start to read the file from Dropbox. And in the meantime, while it's downloading, I'm going to do whatever I want to do. I'm going to print something to my file system, or I'm going to send something back to Dropbox. And whenever that is done, whenever that action is done, just call me back. Whenever that download is finished, call me back. And then I'm going to continue. If we could do this, the benefit would be resource utilization. Imagine the scenario where I have a computer which spends most of its time waiting for downloading files from Dropbox and then doing nothing else. Imagine another scenario where you can, in fact, start that download and in parallel do other requests. I think that would be awesome, right? I think that would be just great. So, because that would allow me to use all my CPU cores, that would allow me to use the power of my computer. It wouldn't sit idly waiting for a download. It would work in that time frame. And when the download is finished, it would go back and kind of print the contents or whatever you want to do as a result of that read operation. Now I'm going to show you in very basic terms, I'm going to show you how to do this with Node.js. And it's both simple and mind-boggling at the same time. Instead of doing read file sync, we're going to use the read file function. But here's the thing. The read file function in itself only kickstarts reading this file. If I save this right now, you're going to see an error. It's going to say callback must be a function received UTF-8. Okay. This is an issue. Read file does not work like this. This is not the signature. This is not how you use read file. What you do is a little bit more convoluted. What you have to do is you have to pass a callback function. Now, I hope you're at least a little bit familiar with callback functions from browser programming, from JavaScript. But basically what we do here is we have to call this read file on its own. Okay. And here we have another function that takes an error and data. And then here we do whatever we want to do. So let me arrange the screen a little bit. So here you have error and data. And now let's see what the what we print in terms of data here. Okay. Great. Now we have that buffer again. Sounds cool. How do I get that UTF-8 back? I type UTF-8 here at the second parameter, and now you see the data is printed to the console. It's not, we're not right now doing Json parse, so let's also do Json parse. Okay, here it's almost similar, but is it though? There's an undefined here. What is that? That undefined is actually the return value of this read function. In fact, right now we're not returning anything from this read function. See, this is an input parameter. This is our scope of the function. We're doing an operation here. We're not returning anything. If I don't log the data here, I don't see anything in the console. It's now, this is a clean run, and we see undefined. We cannot log the console because this is not a synchronous operation anymore. What you can say here is, let's put console log reading and report name. And so we're reading balance sheets. It's undefined. Would it be right to put red report name here? Reading balance sheet, red balance sheet, and then we have the undefined. That is where we are with console log. This is right now printing the return value of this read function, and we're not returning anything. If I return 5 here, it's going to print 5. Let's have the console log here and return 5 here. It's actually going to return 5, and then you're going to see the contents of the file. Now, this is confusing. This is very confusing. We wanted to read this balance sheet. So we have reading balance sheet, and then we have read balance sheet, but where is it? And then we have return 5, and we are logging it here. And then we are actually printing the balance sheet, printing completed, and only then we have the file here. Only then this line works. This is weird. This is mind-boggling. We changed the order of execution significantly. This doesn't really work. So what I should do in this case is to perpetuate this callback. Unfortunately, right now I'm reading this file asynchronously, which means this code will not work anymore. You know, let's remove the console log here, just say reader.read, and let's save it. You're going to see reading balance sheet, read balance sheet, printing, and printing completed, almost like here, but I would expect the balance sheet to be printed to the screen in between these two lines, but then it comes afterwards because it's an asynchronous task right now. But these are happening synchronously. Synchronously, we're kicking off the reading, and then synchronously, we're printing the balance sheet, the bank's balance sheet, to the file, and then we are reading balance sheet.json. That's an asynchronous task. That goes at the end of the queue. After we finish all the synchronous work, we go to the very end and do the asynchronous work. So in order to get around this, I need to introduce a new variable here called callback. Okay. And instead of logging the data here, I'm going to call that function. Essentially, I'm saying I'm reading this file, and when I'm done here, I'm going to call you back. And as a user of this function, I say, okay, when you're done, call me back, because I'm going to log it to the console. Now, here I do reader.read balance sheet, and sheet console log sheet, and then printer.print. See, this line is coming first. It's before printer.print, but the result comes after the printing operation. It's even like I have the console log reading here and console log read here. These are also after, these happen also before reading the actual contents of the file. So this is a bug. First of all, I don't have a return value right now. And second, when do I read the file? I read the file here, console log read or read. And now you see, this is a little bit more interesting. Now, this is where I got this file, the contents of the balance sheet. Let me make it a little bit more easier to read. I said reading, report name. I said read file. And then I called the callback. So I said, okay, I read the file. And now I'm calling you back. So this is the file. Do whatever you want with it. And in index.js, I'm logging it to the console. And after that, I say, okay, I'm done. I'm read. I read this file. I read the report. And I say read balance sheet. Now this makes a little bit more sense. If we remove printer.print, you're going to see how much more sense it makes. Reading balance sheet, we read the balance sheet, and then we read the balance sheet. But look very carefully. If I introduce printer.print, what you have here is reading balance sheet. Great. What do I expect from my previous run? I expect to see the JSON or JavaScript object, and then I expect to see read balance sheet, and then I expect to see printing. But what happens is I see reading balance sheet, then I see printing. This is a problem. And then I see printing completed, and then I see read balance sheet. Why is the problem? It's a problem because this is harder to read. This code is inherently harder to read and reason about. There is kind of an implicit knowledge that tells you that this console log will execute after this print statement. But that's how it goes. Even though it's harder to reason about, this is unlocking so much potential of utilizing your servers. Because what this actually tells you is if you do your I/O asynchronously in a non-blocking way, just like this, reading a file asynchronously, while the operating system is preparing that file, or while Dropbox is sending that file to you, you can go on with your life. You can print stuff. And that's what we did here. See, reading balance sheet, while the operating system is preparing that file, balance sheet.json, what we do here is we are able to print a new balance sheet, and then we get the contents of the file. If this is confusing, we can also just say, console log step 3. Let's do console log step 1 here, and maybe let's say step 2 here. And then step 1, step 3. Let's make it step 4. Let's add console log step 2 here, and let's add console log step 3 here. Okay. Let's make this 5 because I want to add console log step 4 here. Now, let me get rid of all the other console logs. So you're going to see now what we created. We have step 1, then we have step 2, then we have step 5, then step 3 and step 4. This line executes, and then this line executes. They're still synchronous. And now instead of step 3, I moved to step 5 because I said, okay, operating system, please prepare this for me and let me know. Call me back when you're prepared. This is that function. And the operating system goes on preparing the file, and Node.js goes on executing the next line. That's why you have step 5 here. And then once the operating system is done, it calls us back and says, hey, Armağan, your file is ready. And then this block executes, and we have step 3, okay? And we had a client, Index.js, and we say, hey, Index.js, your file is ready. It's like the operating system is calling us, and then we're calling Index.js. That's why we go back here and do the console log here. This is the callback function. And finally, we have step 4 here, okay? You could also do another console log here. After the sheet, for example, let's do what step is this? Because it's a little bit confusing. Let's see the order. So step 1, step 2, step 5. I have completely skipped over this part. This is a callback function. This is gonna execute when somebody calls us back. And then we have step 3 here. And then we have the sheet, and then we have what step is this? And then we have step 4. Okay. Let's add another log here. I want to print a sheet, please. And you see now, step 1, step 2, step 1, step 2, step 5, then step 3. Then we call the callback and say, I want to print a sheet, please. And then or let's say log a sheet, please. I think this is gonna be better. I want to log a sheet, please. I log the sheet, and then I say, what step is this? And then we go back to step 4. What happened to step 5? It executed already. Because we were waiting for the operating system. Why should we wait? If we have work to do, we shouldn't wait. If you have work today, don't leave it to tomorrow. Be done with it immediately. This is the philosophy of Node.js. This is the philosophy of non-blocking asynchronous I/O. And I'm just simply in love with it. I know it's a little bit harder to make sense of at this point. And you can actually write this a little bit in a little bit more simpler way by using promises and async await keywords. But we're not going to get to that part. I leave that to you as an exercise. That's a little bit more advanced. That would be Introduction to Node.js 3, asynchronous programming. That's actually what we do at Coyotiv. So Coyotiv is a school of software engineering where we train career changes, absolute beginners in the way of software engineering, and we give them the confidence and everything they need to know technically to become great software engineers in either a full-time program, a part-time program, or a self-paced program. And this is one of the topics that we're discussing at Coyotiv School of Software Engineering, all the implications of synchronous programs, asynchronous programs, different syntaxes, callback syntax, promise syntax, async await syntax. So in this basic lecture, we wanted to give you an idea of how asynchrony, I think it's asynchrony, how asynchrony works. Steve, please correct me if I'm wrong. So I think, I'm not exactly sure, but I bet next week we're going to talk about Express.js, REST API development with Express.js. I hope to see you there in the next week's meeting, because that's also going to be a very exciting lecture, a mini lecture. And for now, let me clean this up a little bit so that we have a peace of mind, I'm going to delete the lines that I don't really need. So that it's a little bit easier to consume. You know, nobody needs these lines. Great. It's a little bit simpler. And when I save it, you'll still see, let me also turn on printer print, and you see printer print is completed before we can actually read that file. And I'm gonna do one more thing. I love this. I love to use this. I'm gonna do one more thing. I'm going to simplify this even further. Instead of sheet, arrow function, console log, sheet, I'm just gonna do console.log like this. And bam, you see the same results. Reader.read, balance sheet, console log. Works the same. All right, I will leave it to you to decipher why this magic works. I didn't use a parameter. I didn't use an arrow function. Why does this work? That's a homework for you. Thank you for listening to this mini lecture from Coyotiv School of Software Engineering. It was a pleasure to have you all today. And let's see if I can get back to my video. Perfect. As I said, I hope to see you next week. Next Thursday, I hope. I'm not exactly sure about the schedule. You can find it in the channel. And in fact, while you're at it, why don't you just go ahead and subscribe to the channel, hit that bell so that you're notified of our new streams. We're going to talk about Express.js and REST API development with Express.js. And until then, take good care of yourself, of your mind, of your buddies, and please stay safe, stay indoors. And I hope to see you soon. Bye bye.